What if the tech revolution that's transforming our lives is also quietly draining our power grids? Behind every AI model, every chatbot, every smart tool, there's a massive and growing energy bill. And as AI gets smarter, that power demand is only skyrocketing. Before we dive in, make sure to like, subscribe, and drop your thoughts in the comments, especially if you've ever wondered what it really takes to keep AI running. In November 2024, Amazon's request to buy 180 megawatts of nuclear power for a data center was denied. The reason? It would have given them an unfair edge by bypassing the public grid. That decision highlighted a growing concern. Data centers are using more and more electricity, and AI is a big reason why. For nearly 20 years, U.S. electricity demand stayed mostly flat. Now it's climbing fast. Part of that surge? The rise of AI models that need huge amounts of computing power. This all started in 2012 with AlexNet, a groundbreaking image recognition model that showed how AI could scale beyond the limitations of single GPUs. Since then, AI models have exploded in size, and power needs have exploded with them. In the early 2010s, data centers managed to stay energy efficient, even as demand grew. NVIDIA led the charge with GPUs that were 15 times more efficient over a decade. But then came ChatGPT and the Transformer revolution. Training GPT-4, for example, reportedly required over 25,000 GPUs running flat out for 100 days. That's about 50 gigawatt hours of energy, enough to power a small city for a year. And that's just the training. Inference, when the model actually answers your questions, consumes even more power over time. AI researchers are racing to find solutions. At the University of Michigan, experts are exploring techniques like pruning and quantization to shrink models without sacrificing performance. Pruning removes parameters that don't contribute much to accuracy, while quantization reduces the memory needed for each parameter. These changes can cut memory usage by up to 51%. On the systems side, a tool called Perseus, developed by researcher Jaewon Chung, reduces power waste by synchronizing how GPUs share workloads. Instead of running all GPUs at full speed, Perseus slows some down, so they all finish at the same time, using up to 30% less energy in the process. But can these improvements keep up with demand? Some projections estimate that U.S. data centers might consume up to 580 terawatt-hours per year by 2028. That's as much as 12% of total national electricity use. In Virginia alone, data centers already consume a quarter of the state's power. In Ireland, that figure could reach 1/3 of the country's total output. AI may only account for 12% of data center usage right now, but that's changing fast. If Google AIifies its entire search engine, it may need to add 400,000 new servers, consuming 22.8 terawatt-hours per year. That's nearly 10 times the power of a traditional Google search. So where do these numbers come from? That's part of the problem. Researchers say the 10x figure for ChatGPT versus regular search is based on shaky data. Some from a 2009 Google blog, others from offhand comments by NVIDIA's CEO. Real power data from companies like OpenAI and Google, still under wraps. To fix that, the ML Energy Initiative built its own benchmarking tools. One tool, Zeus Monitor, measures real-time GPU energy use. Their tests showed that Meta's Llama 3.1, a massive open-source AI, consumes under 1 watt-hour per request, far less than what's often quoted for ChatGPT. Despite these gains, researchers argue the biggest obstacle is a lack of transparency. Until companies share real data, we're guessing in the dark. And it's hard to fix what you can't measure. Still, there's hope. Innovations in software, cooling, and chip design are pushing AI efficiency forward. Future technologies like photonic chips and 2D semiconductors could radically reduce energy use while boosting performance. But even as we improve efficiency, we tend to use more of the resource. That's Jevons paradox, and it applies here too. So, will AI bring an energy crisis? Researchers don't think so. If the energy supply can't keep up, progress may just slow down. But history shows that people are pretty good at figuring things out. Want to know more about the next wave of AI innovation? Check out the video in the corner and keep the learning going.